Morning, afternoon, or evening, whatever time you are logging on Year 9 Sports Studies. This is my final lesson linked to the first part of the Rice work that I've set. So, lesson 3. Title is just tidying up loose ends. So, basically, any sort of the slides that I've missed out from lesson 1 and lesson 2, I'm going to cover now in this PowerPoint and go through it. There are more slides than in my original lessons where essentially I've had 3 slides. There's a few more, but obviously we can just rewind and go back through this. It's just easier to have one slide so you can make notes rather than have 50 slides to go through. So if we move on to the next slide. So in terms of this task here, this isn't what we've covered so far. We've touched upon bits, and I'm just going to go into a bit more detail with regards to the different joints and how a joint is made up, and more importantly, the synovial joint. If you have a look, I've changed it, and just looking back through the spec, it only asks for 2 major types of joints to be identified when you come into the AQA exam. So that's why that's been highlighted in red, because on my original Rice project it actually says 3. I've gone sort of A level there, so I'll take it back down to GCSE because I'm a nice guy like that. So it's just 2 major types of joints. So essentially we're going to be looking at a hinge joint and a ball and socket joint. I'll move it on. Essentially all I would be after in that student response section is you just to type down your answers based on the information I'm going to give you now, and potentially add in a diagram of a synovial joint that I'm going to go through at this moment in time. I'm going to move on to the next slide. So this is from lesson 1. That you should be aware of. I am going to move into just this middle section where it's got the hinge and ball and socket joint. Now I've already gone through this, but I just want to go a little bit more into detail and talk about this a little bit more, because there's some exam questions linked to this at the end of this PowerPoint that also are on your Rice project. So if we start just above the hinge diagram and just go back through. So remember we were talking about cartilage in our first lesson, with it being at the ends of the bones, and it's there to reduce friction on the bones and essentially acts like a shock absorber, so like suspension in a car or suspension on your bike. So therefore the bones aren't banging together or rubbing together, and therefore you could imagine what an issue that would be. If you've ever heard of a footballer, a rugby player damaging their cartilage, this is what this refers to. They generally tear their cartilage because the cartilage goes around sort of the ends of the bone, so they may make a small tear in it, and what the surgeon would do would go and repair that, either put it back down or remove that bit of cartilage completely. However, that'll mean that the footballer, rugby player's cartilage will be thinner in that joint, and therefore won't be as effective. So you find that these footballers that have these cartilage injuries tend to have problems as they get older. When we look at ligaments, remember we've got the attached bone to bone, and the idea is they create some stability to make sure that the joints don't dislocate. And our sort of more important or more famous ligaments are our anterior cruciate ligaments that lie within the knee joint. And again, this is a very common football injury. So if those joints go, the stability of the knee goes, and it's a long process back once they do that. They actually, as a surgery, remove part of your hamstring, which we should remember from lesson 2, and use that as a new ligament and create that as the new cruciate ligament 4 inside the knee. Tendons join bone to muscle, and they are strong and flexible, and essentially when the muscle contracts, the tendon pulls the bone to obviously facilitate movement. If we move down to the hinge and ball and socket, so like I said, with the slight change to your Rice project and on the previous slide is that you just need to know about 2 synovial joints. So the first one's the hinge joint. Again, we went through this in lesson 1. So we can find the hinge joint in the knee and elbow, and they only have 2 ways of moving. Extension, so increasing the angle at the joint, So if we were to kick a football, extending our leg out, so a straight leg, and flexion, so in football, if we're going to do that and we're kicking, bringing the foot back towards the butt to create a flexion at the knee. We've got the ball and socket joint, which again can be found at the shoulder and the hip. And again, that's got lots of different movements. So we can extend and flex, which I've just discussed about the hinge joint. And we can do abduction. So we take the body part away from the center of the body. And we do adduction, where we add the body part back into the center of the body. Remember, we've got rotation in there. And remember, rotation's a bit like a screwdriver movement. So if you hold your arm out and do a screwdriver movement from there. Again, that's available at the shoulder. And remember that we can do circumduction at the shoulder as well when we essentially do a bowling action in cricket. For that task that was on the previous slide, you've got to basically label a knee joint, and I'm going to go through that. And again, as I would like you to do is I would like you to get, as best you can, a blank version of the joint diagram, and the knee joint is a hinge joint, and you've got to label it. So if we move it on to the next slide, this is a synovial joint, and I've just picked the knee joint because it's got lots going on in there. It looks complicated, but if we follow the arrows, it'll be quite straightforward. So I'll discuss what synovial fluid is and why these joints are called synovial joints, basically because they have synovial fluid in them, but I'll discuss that as we go around. This is our knee joint, and I'm going to start at the bottom left with the ligaments, move my way around in a circular format, and finish at the bottom right where it says synovial fluid. So if we have a look, we've got our ligaments there, which are those blue structures, and as we can see, ligaments join bone to bone. They are actually, in this diagram, they are your anterior cruciate ligaments. So again, they crisscross, and that is keeping the two bones attached at the joint and creating a bit of stability. So you can imagine if that's injured, then the two bones will become loose if they don't have the ligaments in there to support the structure. If we move up, we've got something known as the synovial membrane, which is just that area at the back of the joint. And this is just a lining inside the joint capsule just being sort of the overall area of the joint that keeps everything in together. And this secretes synovial fluid. Now, synovial fluid is like a lubricant, and as you can see on that bottom right hand side, it discusses that it lubricates the joint and stops the bones from rubbing together. So it's a bit like an oil that's in the joint. So if that wasn't there, that joint wouldn't move as well. The more often you use the joint, i.e. in sport, the better that joint becomes at secreting synovial fluid, and you generally get more synovial fluid in the joint. This is also one reason why we warm up. We warm up to make sure that the synovial membrane secretes the synovial fluid so our joints are actually warm and ready to move efficiently. If that synovial fluid was not there, then it would just be the bones rubbing against each other and the cartilage would run down. Like a bike chain without any oil, it just isn't going to work as efficiently. The joint capsule I've discussed, but we'll go back over, is essentially the area of the whole joint, and it just makes sure that the synovial fluid does not leave the joint and escape, so it just contains it. Tendons. So we've got a tendon that runs down from our quadricep, and they are non-elastic cords that join the muscle to bone. And as we contract, that will cause the bone to move. And in this case, if the quadricep was to contract, it would move the top bone, which is our femur, and cause that extension or flexion. The next point is just in front of your kneecap, you have something called a bursa, and it is a sac filled with liquid floating inside the joint to reduce friction between the tendon and the bone. So obviously that's just a little bit of a shock absorber, and as you can see, I've got an arrow to the front, but also behind the tendon you can see that yellow and green sort of splodge. That is also a bursa, and it just means that obviously if the tendon was rubbing up and down the bone, it would damage it. So imagine a rope rubbing down sort of a sandpaper yeah, it would eventually rub the rope out and it would start the damage, yeah, and fray off. So obviously we want something in between the tendon and the bone so the tendon has a nice healthy feel to it and moves efficiently. Cartilage we discussed earlier, but as you can see I've got 2 arrows pointing from there and they just outline the sides of the bone and make sure that the bones don't rub together. Now again, we've got lots of fluid in there and we've got ligaments and stuff, but at some point when we're doing sort of high impact injuries like changing direction or jumping, the bones will push through the synovial fluid and tend to make contact at times. Therefore it's good to have the shock absorbers in there so the bones don't get damaged. Synovial fluid I've discussed, which is obviously secreted from the synovial membrane. It means that we've got lubricant within the joint and it just allows that joint to move a lot more efficiently. And as I said, warm-ups are really good for this because it means that the synovial fluid gets into the joint but also warms up, making it sort of easier to move around the joint, and i.e. makes the joint a lot smoother to move as well. Okay, we're going to move on to the next slide. So, as I stated at the beginning, this is a tidying up area. So there's 2 slides that I haven't really covered in lesson 1 and lesson 2 because they don't really relate to the PowerPoints that I'd put together for this. For example, the skeletal system and the muscular system. The investigation probe, so you've got to read the article on the hyperlink and summarize the key facts about the human body in the student response. On the right hand side, I've just shown you a way that I think would be best to highlight your student response. You would click on the hyperlink for The Guardian and go through. There are 10 facts in that article about the human body. What I would like you to do is just summarize each fact. So I've put 10 arrows on there. So you would just have fact 1 and have a summary of what that fact's about. And when you go through the article, you'll notice that the information in there isn't a lot. So therefore you could break it down. Please don't just copy and paste and stick into the text box. Can you read it and then put it in your own words? I would number each one. So for example, if we would look at the top left corner of the rectangle, that first arrow, I would have that as number 1, middle top 2, right hand side of the rectangle 3, and so forth, all the way back round to the start. So that's all I want you to do in there. Read through the article and just summarize each fact in your own words of what you understand about it. So hopefully that clarifies what that task is about. I'm going to move on to the next slide. So this was the other task that we haven't covered in the 2 RICE lessons already, or in the skeletal and muscular system. And again, it's another article. Again, there is a student response section, and what I've done is try to give you a way of presenting your information so it's a little bit better and hopefully a little bit simpler for you to understand. Now, this article's very, very detailed and it has a lot of information in there. What I would like you to do is pick out 4 bits of information that you agree with and 4 bits of information that you disagree. So for example, in that article, there is a scientist that states that he believes in 2030, so in 10 years, that people will be able to go to sort of shops, essentially in the hospitals, and basically get an MOT on their body and get things sorted. So he's talking about in 10 years' time. I don't think that would personally happen. I think there'll be some degree of that, but not in the way he's talking. So therefore, in the one fact that I disagree, or 1 bit of information I disagree, I would highlight that, copy and paste it into the number 1 section, say I disagree with this. And you've just got to find 4 things that you agree with in the article and 4 things that you disagree in the article. They don't need to sort of bounce off each other. So if you were to put something in that you agree with, you don't have to find the complete opposite in the article. It can just be 4 random agree facts and 4 random disagree facts from the article. So hopefully that's a bit straightforward with that one. I'm going to move on to the next slide as well. So in this part here, what I would like you to do is essentially pause the video and I would like you to have a go at these 2 exam questions. So exam question 1, give an example from the skeleton of where a hinge joint can be found. Question 2, give an example from the skeleton of where a ball and socket joint can be found. Have a look at the mark scheme it is just 1 mark for each, so you don't have to write a lot. You can just state the area. So pause it now and then answer them and then replay this once you're done. Right, I'm taking that you have paused it and I'm taking that you've now pressed play. We're going to move on and have a look at the answers, and therefore we can see what people have got down. Hopefully you got this right, because we've literally just done it about 2 minutes ago. So this is what you have in your RICE project. So it's an AO1 answer, which means it's very basic. So where would we find a hinge joint? We could find it in the elbow, the knee, and the ankle. The ankle's a bit of a grey area because it does have more range of movement than extension and flexion, because it can do circular movements, but it is still classed as a hinge joint because it does plantar flexion when we plant our toes into the ground, and dorsiflexion when we bring our toes back towards our shin or our tibialis anterior muscle. Give an example from the skeleton where a ball and socket joint can be found. There is only 2 areas, the hip and the shoulder. So hopefully 2 pretty straightforward answers. And again, these have been past questions on previous exam papers. Moving on to the next slide. So we've gone through this earlier, so that's why I had that diagram in, just to sort of clarify where different areas are. So again, what I'm going to go through is I'm going to read the question out and explain how I would answer this. Then I would like you to pause the video and then go through. Please don't cheat and just fast forward it on to the next bit, because you're not going to gain anything from it. So we've got obviously a diagram of what looks like a hinge joint, diagram of a knee joint. We've got 2 areas that we've got to identify. So we've got structure A and structure B. 2 marks, 1 for each. So you've got to tell me what the label of A is and what the label of B is. Then in the question B section of this exam question, for one of the structures identified, so A or B, you've got to write the structure name down, and then you've just got to write down its prevention of injury. So what's its structure for? So again, what's its function? So again, please pause the video on a bit of paper or on your RICE project. Have a go at this exam question. Right, I'm assuming that you've paused it and then you've come back in. So let's have a look. So it's an AO1, so the 2 areas, we've got the cartilage, because it's that grey area round the outside of the bones that stop them rubbing together, and we've got the synovial fluid, again, that lubricant within the joint. Should be getting 2 marks for that because we've just done it within the lesson. Again, my arrows might not be pointing exactly the same as in the exam paper, but again, you still need to know the different areas of the joint. So if we have a look, depending on what you've chosen, if we look at cartilage, it absorbs shock and acts as a buffer between the bones, prevents the bones rubbing together, reducing friction. So again, if I was you, I would have probably picked A because it's the easiest one to remember. Synovial fluid, it lubricates the joints, it prevents the bones rubbing together and reducing friction, and it again allows the joint to run smoothly. So I think that's an easy 4 marks as long as we've listened to the previous slide and done our little bit of research as well. Right, we're going to move on to the last slide. So this is our last exam question, to be more precise. So exam practice. So this is a bigger question. This is the largest question I could find from past exam papers about the topic areas within your RICE project. Explain the role of the skeletal system in producing movement of the body. So again, things that we're going to have to think about. What does the skeletal system do? How do joints move? So we're going to have a look at muscle contractions and what types of movement are there. What articulating bones create joints? So there's quite a lot to go through. So once again, using your notes from lesson 1 and lesson 2, can you have a go at this exam question and pause the video? Right, again, there's no way of me checking, but again, the only person that you're harming is yourself if you're cheating. So, explain the role of the skeletal system in producing movement of the body. So, the skeletal system allows movement at a joint. Yeah, we've got short bones enable finer control movements, whilst longer bones enable gross movement. We've got the different joint types allow different types of movement. We've got what the hinge joint does. So the hinge joint allows extension and flexion, whilst the ball and socket allows flexion, extension, abduction, adduction, circular motion. That is all on the same mark point. So if you said hinge joint and ball and socket joint, you can only get one mark. You can't get two separate marks for the two different joints. The skeleton provides a point of attachment for muscles, and the muscles contract and they pull the bone. So remember, the question is how the skeletal system is involved in producing movement. So we don't want to know about protection. We don't want to know about red cell production. We don't want to know about minerals and vitamins being stored. We want to talk about how the skeletal system allows movement. Well, it's got joints, so that's one way of movement. We've got it allows muscles to attach to bones. There's another point. Muscles contract, they pull on the bones. If you want to be a bit more specific, they pull on the tendons. The types of joints and types of movement we can get. I think the hardest bit of this would be talking about the short bones enable finer control movements, while long bones enable gross movement. I think that's a tough one. So that will probably, out of the 5 marks, be the one that I think, or the 6 marks that are available on this mark scheme, would be the one that I expect most people to drop. Right, my advice to you is this, is if you're unhappy with this, is to go back through lesson 1 and lesson 2 and go through the PowerPoints that I've got the information on. Either mute me if you've got bored of me, and then make notes on it, and then have a look at some past exam questions via AQA. You can find all the past papers and have a look for questions that link to the skeletal system and the muscular system, and more importantly, how joints move regarding sort of the agonist and antagonistic muscles, and then have a go at them for some additional practice. I will be setting more stuff on SAM Learning, and then hopefully I will be setting one more RICE project with some PowerPoint voiceovers to just for you to keep yourselves ticking over the summer. Right, that's the end of this one. Goodbye.